Welcome to LMS Solution. Today we are going to see about fuzzy logic based scalar control of induction motor. So this is a Simulink model development for that fuzzy logic based scalar control of induction motor. Here you can see that we have different elements. This is a DC source, and then this is voltage source inverter, and this is induction motor. Here we are going to use fuzzy logic based speed control as well as PID based speed control. In order to apply that scalar control for induction motor, first you have to measure the speed of the induction machine. The speed of the induction machine is 300 radian per second. That should be converted into revolution per minute. For that you have to multiply it with 30 divided by 5. So it's going to be converted into RPM. So next you have to fed back this here. This is going to be compared with the reference speed. And then here we have error under rate of change of error. The calculate error rate of change of error. That going to be input for that fuzzy logic controller. The fuzzy logic controller output nothing but the omega SL. That means shift speed. So the shift speed and the actual speed of the machine going to be added together. So this will be provide the actual speed of the induction machine you have to maintain. Next, that actual speed going to be converted into frequency here by using this gain parameter. Like you have to use that formula nothing but 120 concept. You just you have to calculate ns equal to 120 p. Just you have to calculate f equal to p into ns divided by 120. By using that formula, just you have to calculate frequency. That frequency going to be converted into amplitude. That means per unit amplitude here. That means we are going to divide that frequency, actual frequency with 60 hertz. So it going to be converted into the per unit amplitude. And then here we have to that based upon that frequency, you have to generate the sine wave, three-phase sine wave here. Finally, we'll get the three-phase sinusoidal waveform here, reference sinusoidal waveform. It contains the nature of voltage slash F concept. V bar of concept. The voltage and frequency simultaneously vary according with the speed of the induction machine. Next, that signal reference voltage signal. Voltage becomes a signal going to be used for generating the pulse. This is going to be taken here. Here we are going to compare that three-phase reference voltage frequency signal with the triangular wave. It will generate the pulse for the voltage source inverter. So this is going to be control the voltage and frequency of the induction machine in order to maintain in order to track the reference. So this is the concept of fuzzy logic based scalar control of induction machine. And also same way here we are using PID controller. So the PID controller is used for regulate the speed in order to provide the shift speed here. Next I'm going to simulate this model. I'm going to compare both the fuzzy logic and PID controller. Here I'm going to set the reference speed. Initially is 1500 rpm and then finally it going to 1000 rpm after 5 seconds. Now I'm going to operate this system with the PID controller, and then you have to check the response of the system operated with the PID controller. Here you can see that this is the response of the induction motor speed. It is having overshoot as well as undershoot, and then it take time, that means around 3 seconds to reach the reference speed initially. After 5 seconds, the reference speed command is changed from 1500 rpm to 1000 rpm. And also you can see that it have undershoot, and then it take around 1.5 seconds to reach the reference speed command. Just I'm going to take this detail in order to compare with this response with the fuzzy logic response. So next I'm going to operate the same system with the fuzzy logic based controllers. Here I'm going to simulate this model. Here you can see that the response is very smooth. It's like a overdamped nature. So, and also it reached the speed around 1.25 seconds. Here you can see that it reached 1.25 seconds, and then after 5 seconds speed command is changed from 1500 rpm to 1000 rpm. You can see that it's quickly settled to that 1000 rpm without any undershoot, overshoot. You can compare the both result of PID controller and fuzzy logic controller here. This is a response of the PID is the response of fuzzy logic controller. Here you can see that when it have the PID controller have overshoot and undershoot, and then it take 3.5 seconds to reach the reference speed command. But you can see that in fuzzy logic controller it does not have any overshoot, and then it reach the reference speed command very quickly, just around 1.25 seconds. And then you consider that when change in reference bit command occur here 5 seconds from 1500 RPM to 1000 RPM. Here you can see that it have undershoot, and then it reach around 6 point. That means 5 seconds is changing. From that, that means it will take around 1.2 seconds to reach the reference speed command. But here you can see that fuzzy logic controller, after the reference bit command change, it will take only around 0.5 seconds to reach the reference bit command. When comparing with the PID controller, the fuzzy logic based scalar control have better response than PID controller. So this is a working of fuzzy logic based scalar control of induction motor. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming. Thank you so much.